All right, greetings YouTube. This question comes in on from College Algebra. It says, use a quadratic formula to solve. So one suggestion is whenever we use a formula, we write it down. That helps us to ingrain it into our memory. So if we're going to use the quadratic formula is the following. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, okay. So let's go. It's probably a good idea to go ahead and identify A, B, and C. Let's do this. So notice that our function is already in standard form. So it's ax squared plus bx plus c. So then we can just take it as it is. So then we can say our a ends up being 0.2, our b ends up being a negative 1.2, and our c is negative 0.2. Okay, so we can just take those and plug them into the formula. So then x is going to be negative b, so it's going to be negative 1.2 plus or minus the square root of negative 1.2 squared minus 4, a is 0.2, and c is negative 0.2. And take the square root of that result, all divided by 2a. Okay, you could just put it in the calculator just like that. Let's see if we can pull up our calculator. Okay. So the numerator, we have negative, open parentheses, negative 1.2. Let's do the minus first. Then we're going to say square root. Now we need another set of parentheses, negative 1.2, close parentheses, squared, minus 4 times 0.2 times negative 0.2. That closes this off. This closes off the square root. This should close off the numerator. Then we're going to say divided by the bottom, which is 2 times 0.2. Closes that off, and that closes off the bottom. Okay, provided we didn't make any mistakes, and we'll check it. We get, and since everything goes, it says simplify right here. Simplify the answer, type exact answers using radicals as needed. Okay, so we don't want that decimal. Okay. So type exact answer. So we're not going to use this decimal. So if that's the case, let's back up and do the following. Let's find the discriminant. So we're going to say the negative 1.2, close parentheses, squared, minus 4 times 0.2 times, I think that's a negative 0.2. I think we're good there. Okay. So then what's the square root of 1.6? Okay, so it's not necessarily a perfect square. We'll look at one other thing. Now what we could have done, honestly, in the beginning was multiply the left and the right by 10. I started to do that. Let me just see what happens if we do that, right? So let me kind of put a pause here for a second. Not to say that what we have is wrong or anything. It's just something I wanted to kind of explore. So if we take the original, I'll keep it, whatever. So if the original is 0.2x squared minus 1.2x minus 0.2 equal to 0. I just want to see what happens if we multiply the left and the right by 10. So if we say this times 10 and this times 10, so we would distribute, and let's see what happens. So then that becomes 2x squared minus 12x minus 2 equal to 0, right? Then I'm going to go ahead and divide everything by 2. I'm going to say the left divided by 2, right divided by 2, and we can distribute like this. Just to see what happens. So then that cancels. That's going to turn to a 1. That's going to go to 0. This goes to 1. This goes to 0. So then if we do this, we'll get x squared minus 6x minus 1 equals 0. Okay. So then x would be negative b, which is a 6 plus or minus the square root 36 minus 4 times a times c times 1 times the negative 1 over 2. Let's see what happens. Just kind of playing around. 6 plus or minus 36 plus 4 becomes 40 over 2. That's a 4 and a 10, so then that's going to be 6 plus or minus 2 root 10 divided by 2, and we get 3 plus or minus the square root of 10. Now this is the result I get. So one thing we could do, now we did get a result earlier. We got that, I think when we did the whole thing, we got the negative 0.1622, all of that. Let's plug this in and see if we get the same decimal. 3 minus the square root of 10. It looks like we did. Okay. So now I'm going to check this in the original, right? We got 3 plus or minus the square root of 10. So there's our original up there. I'm going to go to my y equals. I'm going to put in the original. 0.2 x squared minus 1.2 x minus 0.2. So now when we put these results into the original, we should get 0. So if we go to variables, y variables, and then we put in y1, we said 3 minus the square root of 10. Okay. We should get 0. And then we say 3 plus the square root of 10. We should get the same result. That's practically 0. That's times 10 to the negative 13, which is a really small number, which is practically 0. So that should be fine. Let's see. So this is a prime case. In class, we typically, whenever I have decimals in the beginning, I get rid of them by multiplying by the appropriate power of 10, as you see right. So right here where you saw me multiply by the appropriate power of 10, this is why I kept doing it in class, because sometimes it is easier to keep the decimal. In this case, you saw what happened. We got that long string, and then it was harder to get to a result like what you see here, right? So then I went back and redid the question where I multiplied the left and right by the appropriate power of 10. In this case, you only had one, the longest decimal had one decimal behind the decimal point, so that's why I multiplied the left and right by 10. We got this result, and then you saw how now we were able to get an exact result with radicals, okay? So we got this result, and we checked it in the original. Let's go. So there was a request for another question, which is number 20, so let's take a look at it.